Good morning, class. Welcome to this lesson on dimensional analysis. I would like to remind you that I would like you to set up your notes in the Cornell note style with a left-hand column set up for 3 questions and an area on the bottom for a summary. So this lesson on dimensional analysis. Dimensional analysis is probably going to be the most important tool that you have in your toolbox of things in order to help you solve physics problems. I'm going to say that again. It's probably going to be the most important tool you are going to use for pretty much every single problem that we're going to work out. So what is dimensional analysis? Dimensional analysis is very self-explanatory. It is analyzing the dimensions of a problem. Now, every single number has two parts. There is the actual number part, and we have a fancy term for that, and that is called the magnitude. And then there is the unit. Then there is the unit, or the dimension. So for example, we can have a very, very basic unit like 5 meters per second. 5 meters per second. So that we have a number, or the magnitude, and then we have the unit. It's not just 5 nothing, it's 5 meters per second. Okay? So, when we are working a problem, we are going to analyze the dimensions to make sure that that answer is correct. So, let me start out with some very basic things here that we're going to learn in class as well. Typically, when we have a x, or sometimes a d, these are units of distance. These are units of distance. And we use meters for distance. Okay, we have v, that is velocity, and we usually measure this in meters per second. And then we have a, which is acceleration, which is meters per second squared. Okay, so these are some very basic units that we're going to learn right off the bat in school. So let's do a very basic problem. Let's say we have this equation right here. We have x equals 1/2 VT squared. X equals 1/2 VT squared. Now, I want to analyze the dimensions. So I know that in this problem, my answer x needs to come out into meters. My answer x needs to work out into meters. Now, this 1/2 right here, this is a number. This is a magnitude. We're not worried about any numbers in this. We are not worried about any numbers in this. We are only worried about the dimensions. I know that v is going to be meters per second, and I have t squared. Oh, I'm sorry, I did not define t up here. T is a unit of time, and we measure that in seconds. So t squared. So whatever number I have here is going to be t squared. So it's going to be seconds squared. Now, in a normal problem, there would be numbers here. There would be 1/2, maybe once again, 5 meters a second times 2 seconds squared. But right now, in dimensional analysis, I just want to look at the dimensions, not the numbers. So, if I work this out, I have meters per second times seconds squared. Well, using my algebra skills, I know that this second here is going to cancel out with one of these here. So on the left side, I have meters, but on the right side, I have meters times seconds. So if I did this problem, this would be wrong. Before I even looked at my answer, before I did anything else, I know this problem is wrong because the units, the dimensions, don't work out. I was trying to find meters, and I got meters times seconds. So something went wrong in my equation. I need to work that out. So, in the same way, let's try this one. Acceleration equals velocity over time. Acceleration equals velocity over time. Acceleration is going to be meters per second squared. Velocity is meters per second. And time is seconds. So, and we notice here that time is on the bottom of the fraction. So over here is going to be on the bottom of the fraction as well. And so if I work this out, meters times 1 is just meters second times second is meters per second squared. So on the left side of the equation, I was making sure that my answers were going to end up in meters per second squared. On the right side, it ended up being meters per second squared. So I know from this, from looking at this, that this is correct. Or at least I'm reasonably sure it's correct. Just because the dimensions work out doesn't mean it's always correct. But if they don't work out, that means it is definitely incorrect. So this is, once again, this is one of the most important tools we're going to use in this class. It's basically checking your work in another way. And so if you're always checking your dimensions, you can always see right off the bat if you are on the right path or if you are not on the right path. Thank you.